So we can use Cramer's rule to solve this 3 by 3 system. First of all, set up the matrix D, which comes from the coefficients of x, y, and z. So it's going to be a 3 by 3 matrix, 3 rows, 3 columns. In the first row, we've got 1, 1, and 0 for z. In this one, we've got 0 for x, 2 for y, and 1 for z. And the bottom one is a -1, 0, and 1 for z. And now for dx, take the first column, which is for the x's, and replace it with the -4, 0, and 5. Otherwise, the matrix stays the same. And then for dy, put those constants in the middle column, but go back to the original coefficients for z and the original coefficients for x. And then finally we do the same thing for dz. So the x and the y coefficients are there, and then for the z, replace it with the constants -4, 0, and 5. And now I need to calculate these determinants. So I think I'm going to use row expansion. So expanding across this row means that I have 1 times, and then if you cancel out the 1, what's left is this 2 by 2 determinant. So that's going to be 2 minus 0. And then alternate the signs, so the next one's negative. And if we get rid of this middle column, there's going to be 0 minus a -1. So that's going to be a +1. And then this would be its coefficient. And the next one has a coefficient of 0, and so we're done. It's going to be 2 minus 1, there's d. So I could use this row, and it's going to be -4 gets multiplied with 2. And then -1 gets multiplied with, so if this middle column is gone, it's going to be a 0 minus 5. And again, the last one is 0, so we're done. So this is going to be a +5, and -8 is a -3. And then on this one, the best row to use would be this one, because it's got 2 zeros, so we really only need to do the last 1 times, and then if that one's crossed out, what's left is a 5 minus 4. And then the signs alternate. So this is plus, minus, so they alternate everywhere. So attached to that, a negative sign. So it's going to end up to be -1. And again, this one would be the easiest, because we only need to calculate this single 2 by 2 determinant, which is going to be a 5. Hey, that's the same. 5 minus 4. So 5 minus 4 for the determinant. This time the coefficient is a 2. And when I alternated the signs, attach a positive to the front of that. So a +2. So it's going to be just a 2. And then x is going to be, so they all get divided by d, which in this case isn't going to change anything. So this is x, this is y, and this is z. So we've got x equals -3, y equals -1, and z equals 2. So if I were to substitute a -3 and a -1, it would result in -4. That's good. And then 2 times y would be a -2, and then add z, which is a +2, equals 0. So we got it right.